This is routine 100 of the change picture game. Here, highlighted in green, is the first part I want to go over. It sets values in this list called swap trees. Sets the first value to 482, the next to 483. You see the offset in the list called swap trees increases as we go down. These are pictures. I'm going to go down here to pictures, and I'm in set 5, and here's the picture of 482. That's the picture that's going to be put in the forest as a swap. Let's go back. There are 6 trees that are going to be swapped. Once they're put in the list, then it says for I of 0 to 5, one at a time. Well, that means it's going to go around this loop 6 times. Each time it's going to set PS to the swap tree at all set I, where I goes from 0 to 5. Well, see, that's what's in our list here, from 0 to 5. PS is the control register for pictures, the picture number, and if I go down over here and click on control registers, you'll see PS is the picture number for showing pictures. So it's going to go around here, set PS to the swap tree at offset I, and go get the picture. It does this at initialization time, so it gets the pictures before they have to be put on the screen. I now have highlighted another set of instructions in green. First, it says to do an R set. That means to reset all the probability distributions that it has. Because later down here, we're going to use the command or action called PEC, which uses a probability distribution. So here it resets it, so it's going to start at the beginning again. And then it sets G, that's a register, to the game number, M to 60, A to 25, B to 55, and L to 0, and Y to 60, and then it starts to go around a loop on I, starting at 0. That I is going to change down here at next I. We're going to go to 13, one at a time. This is going to be for every row of trees. It's going to go around for every row. Then it's going to go around for every column within the row. And let's go look at the program, and we'll see there are rows of trees. And then there are columns of trees. We go back to the program. When it enters there, it sets the value C to A. Well, you would think that that would be the same all the time, except down here, when it switches rows, it swaps A and B. A was 25 and B was 55. It's going to swap that every time it changes rows, and that's so that it indents the rows. Let me explain. In order to make the forest look like it's random, it's actually, this tree is here, the next row is set over, then back and over and back and over and back to make it look more like a random forest. So that's what A and B do. They offset the different rows as to their horizontal position. Then it sets J to 0, and it's going to go around a loop from 0 to 8, which is 9 times, one at a time. Well, I'll show you something. There are 9 trees in every row. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you go through all the rows, you'll find out there's always 9 trees. But it looks like a forest, doesn't it? Well, the first thing it does, it uses a command or action called PEC, which is going to pick a random number equally likely. That's what the E in the PEC means. Equally likely. how many equally likelies are there? M. And here we set M to 60. So there's 60 things equally likely. But the value this is going to produce is 0 to 59. Now, the probability distribution needs a seed. And its seed is 1 plus the game number. Therefore, every game is going to have a different seed, therefore a different random selection of trees. The next thing it does is it adds 416 to the number that it got. Remember, that's the picture number. Now we'll go back to pictures, and I'll show you what this means. If I go back to set 4, this very first tree is tree 416. What that random distribution is doing is it's saying I'm going to start at 416, you give me a random number between 0 and 59, and that selects which one of these trees I'm going to put next in the list. So there you go. So it sets the picture number of an offset L to that picture number. Then it says, go get that picture. Then it does another random selection, again, over 60 things that are equally likely. So it's going from 0 to 59. But then it divides it by 3. So it's going to go from, less than that. It's like going to go from 0 to 19. And then it adds that value to K, that of the X, the X position that we had set previously to A or B. Here it set C to A, but we know that A changes back and forth between 25 and 55, so the offset for each row changes. But it also randomly selects an additional offset horizontally. Then it defines the position of that particular tree, its X value and its Y value. The X value is set to this value of K, and the Y value is set to YS, which started at 60. And down here we're going to see that YS is going to be increased by 25 each time. I'm going to go back to the picture. This first row of trees is at offset 60 from the top. Y is 60. The next row is 60 plus 25, and then another 25 for each row. It looks like a random forest, but you're finding out these trees were positioned. After that, let's see, we go down here. Okay, we're going to add 50 to C each time. C is our X position. So it's going to move over horizontally 50 each time, and we're going to increase our value of L. L is the offset for our X and Y positions. Each time we find a new position, as we are going around these loops. There's our increase of Y by 25, A being swapped with B, and here we're going around 0 to 13 for the rows. Now I've highlighted another group of instructions in green. The first one says take all the picture information that we developed up here and move it to another list of positions at changed PS. Then set NG to the value of L. Now L was increasing every time we found another tree position. But then it says subtract 1 from that, because when we go around a loop, we always go from 0 to a value. So it's going to be one less tree than that. Then we set J to 0, and we're going to go around a loop on I. From I of 0, and down here is the end of the loop. It says I is going to go 5 to 5, one at a time. It's going to go around 6 times. The next thing it does after it starts I is it does a peck. Remember, that was equally likely of 60 things using the same seed number but we didn't do a reset, so it's going to go get the next random number for that seed. And then it's going to add that k to the j value we started with. So it's going to randomly change the value of j. Then we set our picture number to j. But remember, our random selection must be within the values of 0 to ng. So it mods it with ng. But then it says, what happens if maybe I selected the same tree position already? Well, I can't have one of the selections twice. So it does a check to see if the number put at that position is greater than 481. That means it's one of our swap trees. Well, we can't use that position because we swapped it already. So it says can't do that, so it goes picks another random position. When it knows that that position has not been used before, it says, okay, the change position now is set to that swap trees picture. And then it says, oh, my x and y values then for that position are going to be put in my answer positions for x and y. And we're going to go around here until we have all 5 trees that we want to swap. All right, this is the end of routine 100 and change picture game.